Hello, everyone. These days, in our seminar activity, we have changed the scenery a little bit. We moved away from a podcast studio and we are using some light, some sun. And also we are now focusing on use cases of artificial intelligence, in particular in manufacturing, obviously. Today we want to discuss a interesting case of how artificial intelligence is helping in visual inspection process. When we think about AI analytics and visual inspection, well, one thing that comes to mind is that it could be very complex. And today we will be trying to tackle this topic together with Daniel, my guest, who is responsible for the setup of control products in Mitsubishi Electric factory automation. And we will be trying to show a specific use case where you will see that this kind of process can be actually implemented very easily, and it can be combined with general production processes to improve efficiency without affecting the business stability, let's say. In terms of investing in some new technology which is complicated and requires a lot of people to handle. You will see that this can be done very easily, and this is the whole conversation that we will have today about. Daniel, welcome, and I hope this conversation will be also interesting for you. So you will give us a lot of details on the visual inspection in manufacturing.
Thank you very much for having me today. Yes, I also have to say, as a product manager for the EMEA region, I can see the utilization of the AI visual inspection across all the industries and having a huge impact. And especially, I would say that MELSOFT VIXIO, the focus here was to make a very easy to use software, but having a vast impact on productivity and quality inspection. Mm-hmm. So I'm happy to discuss it today with you.
Right. So let's, more of a seminar style. So maybe let's go through the agenda first. Can you just quickly tell us what you're going to talk about?
Yes. So today we will talk about the traditional inspection system versus AI visual inspection. I will shortly talk about why the software itself was developed, and then also the benefits of AI visual inspection. And at the last time, actually, and I think this will be the interesting part, how we can create within just 5 minutes an AI that will fit to your production, to your products, and has already the very good accuracy.
This topic is especially important these days because in manufacturing there are certain challenges that are affecting productivity of many companies. The one thing that comes to mind immediately is labor shortage, which is clearly one of the heavy problems for many manufacturing facilities.
Exactly.
But that's not the only one, right?
Yes.
This is one of a couple of challenges which are very difficult to tackle these days.
But maybe let's talk about labor shortages. So I believe that everybody understands that visual inspection is a very, on the one hand, important task, but also like a very tiring task. So it's very monotonous. So you're always having the same part that you're inspecting. And it's hard to find new workers for these tasks. So everybody wants to do a little bit more like complex tasks in their work life, not for 8 hours. But for the visual inspection system, you can then automatically pass all of the good products. Only the bad products has to be inspected. So what does it mean for the inspectors? They can take the time where they don't inspect the bad products with other tasks. So they can go to other machines, to the operating of these machines, maybe optimizing something. And after some time, they just come back to the batch of bad products, inspect it, rework. And therefore, it's a very good utilization of the AI inspection system here to tackle the labor problems actually that we have and face at the moment. And maybe coming to the same or similar topic as well is, I think the baby boomers right now, they all go into the pension. So meaning you have all the experienced inspectors that created their experience over a long time. So I was once in a air conditioning factory, and I could immediately spot the experienced worker. They swiftly turned around the products, inspected each point of the air conditioning, and they could rapidly decide, is it a good, a bad product? Can it be reworked? Do we have to discard it? And on the contrary, you could see also the new guys, of course, they want to do the best. They want to keep the quality stable, keep the quality high, so they take a little bit longer, thoroughly inspect everything. But there you can see already there is a big variation in inspection time or quality as well. So also tackling this part, since, I mean, if you are using the AI visual inspection system, you are sure that your quality is always at the same level.
Yeah, because I think it's a very important point. So the one thing is lack of, let's say, skilled people to hire in the company. But the second issue is that even if you have them, it takes tremendous time to train them to the level of those experienced people who are leaving. And yes, we do experience this issue across different industries, that experienced people are leaving their jobs, right? So the knowledge retention is another huge challenge. And I think, yes, some sort of a standard process for visual inspection could be an answer to that.
Yes.
I think you briefly mentioned this, but I think we need to underline that point about how the visual inspection is done today. And it is pretty much heavily based on certain rules, which are, let's say, not always perfect, and that each process requires modifications of parameters of the visual inspection and so on. So maybe you can elaborate on that as well.
Yes, exactly. And I think here also lies in the difficulty that we see at the moment. So everybody wants to have like a one lot production at best. So meaning you have lots of product variants. And in traditional rule-based inspection systems, of course, for each variant, you have to create this huge list of rules. But then on the other hand, also as an expert of the products, I have to think about all the outliers that could come. For example, like you have to think about all kind of defects that could occur. And for sure, we're all humans, and we don't want to spend like hours and months in thinking about what could have happened or what could happen, right? And then for this like very rare occasion, also making a rule. Instead, wouldn't it be much better to have just, let's say, just the good pictures, which are in the tolerance, let the AI learn it, and you're ready to go for every defect that could actually happen. You don't even have to think about it. But for this,
you need the reasoning. The thinking has to happen somewhere else, and I think this is where AI would come into play.
Exactly.
So maybe, because I think this rule-based versus, let's say, AI-based approach, I think that this, let's say, is the easiest to imagine. So could you then tell us how, AI is completely changing the approach to the visual inspection?
Yes, so if you think about it, you are utilizing, let's say, your good products, taking a bunch of pictures that you probably already have, and maybe giving you two examples. So on the one hand, you most likely have already good pictures. On the other hand, the visual inspection system doesn't interfere with your production. So it means you can simply put the camera system on top of your production line, does not interfere at all, and you can gather the good pictures, let's say. And it's as simple as it is. So you just take all the good pictures, train the AI, and then deploy it on your machine. So it's basically a 3-step process, which can be done within minutes, instead of having to create, as I said before, like a huge lists of rules that you need then for each variant at the end.
I think we can agree that let's say adding the visual aspect to the quality control process is not problematic to the most companies, because at the end that will be a module with that simply checks, takes pictures of the product and sends it to the, let's say, analytics software. So how about the software itself? I mean, I think that's one of the common understanding that implementing AI itself is complex, and implementing also to understand the content of a picture is quite problematic.
Yes.
So how do you handle that to actually make it easier for the user?
Yes, you're right. So when talking about AI, also the first that comes into my mind is, do I need a degree? Do I have to be a data analyst? Or do I have to have like special programming skills in order to create the AI model itself? And this was also one of the, let's say, main development parts that we focused on. So it has to be accessible for everybody. It has to be accessible for the operator. It has to be accessible for the development team, or also if there is any new variant being created. It has to be easy. It doesn't have to take a lot of time, and you don't need any programming skills as well for that. And all this inside of our software, which is running on a browser-based environment, so you can use any browser that you would like to use. And this is also the neat thing about it, because everybody knows how to use a browser. And if it's low code, if it's easy to do in 3 simple steps to create your AI and deploy it, I think everybody can do it. And as a matter of fact, also I did it already many, many times by myself on my computer. So it's a piece of cake that I will show you also later on.
But so maybe we should delve into this a little bit. So why then it is not complex as like a traditional AI implementation? How this particular approach is different from let's say, a general purpose AI models that can be used in these applications?
Yes, of course, the AI model here is specifically designed for the visual inspection task. So meaning, in step 1, we are taking good pictures and teaching it for the AI. So the AI is then creating a model specifically for the good pictures. So meaning, everything that is outside the norm, anything that is outside your tolerance or outside of your, let's say, high quality standards, is then being observed, and as soon as there is a bad product coming through production, it will be flagged. And here also it is very important that the operator has a very clear picture of what is the defect. So we have the heat map where you can simply see the bad spots. So then the inspector could say, okay, I can rework it or I have to discard it. So it's a very simple process then also for the operator to decide what to do next at the end. As well, I think what is also crucial for not only the operators, but also for the manufacturing staff, is to see what is the trend of my production line as well. So this is also everything embedded into the software. So you have easy real-time analysis, so you can see each product side by side, what was the defect, what was the quality value. But on the other hand, you can also see the historical quality trend. So imagine you're producing and then you slightly see some shift of quality. Positive is always fine, but negative shift, of course, you want to prevent it as fast as possible. And this is even possible for the operator level. So they can do everything in their hands, maybe shifting some parameters, shifting some recipes. But if that doesn't work, then also the maintenance team, for example, could come and prevent, let's say, the quality shift so that you are producing some bad products.
Mm-hmm. It seems to some extent that because the solution is, let's say, on the factory floor and it is close to the process, it definitely makes it easier to set up and also easier to, let's say, maintain and improve in future, right?
Yes. So I think that the important part here is that creating a new variant, let's say you're deciding to make a new product, just takes a few minutes. So that on the one hand is of course very beneficial for time to market. So you can reduce it quite a lot. And imagine you are regularly deciding to create new variants. This short development of the AI and deployment is really sum up over the years. Mm-hmm. And on the same time also, when thinking about, I would say then reporting, you still have all the tools available to back up your whole process. So if there is, let's say, a recall or you have to report something, everything is done already in the software. Mm-hmm. And as you said, It is all in on the edge level, so very fast, very easy to deploy. And maybe while we are already talking about the edge level, scalability is also an important topic for the MELSOFT VIXIO software. So, I mean, you can do it with just one inspection system, one camera, but also it's very easy to scale it up. Mm-hmm. So you could imagine, for example, one line, one inspection line, you can inspect at a matter of fact until up to 8 inspection lines. So basically 8 cameras can be connected at the same time, and up to 32 AI models can be simultaneously executed, allowing you to inspect not only, let's say, one line, but for example, you have many processes you want to inspect at the same time, or many lines. So it's very easy to scale the whole software.
Mm-hmm. All right, but you also mentioned before about this, let's say, speed of delivery of the solution. But I think this is also affected by the amount of input data, right? So how do you address the point that basically the AI has to learn a little bit about the product to inspect it later?
Yes. So of course, AI is, I would say, always a process. So you can start with as few as, I don't know, like 20, 30 pictures of good quality products. And then after, let's say, a week or so, you are then checking all the confusion metrics, meaning what was your outcome of the accuracy of your model? Are you satisfied with it? Do you want to improve it? And since you constantly gather new pictures, you can then just streamline them, feed it back to the AI. And since it only takes a few minutes, you can then upload the new AI and you have a higher accuracy level immediately. Maybe what I also didn't mention in the beginning was, of course, we always have to think about it. So the human inspector always takes a lot of time to inspect each product, right? But as a matter of fact, with the software, this is just a few milliseconds basically until you have the decision, good or bad product, that you can then proceed. So also benefiting then, of course, your overall OEE by just pushing out more products at the same time.
So maybe we can show it. So you said this can be trained very quickly, and that basically you simply need even like a couple of good images to train a model, and then the decisions are taken quickly.
Yes.
So maybe we can go through this process step by step.
Yes. So maybe beforehand, when I talk about we are gathering pictures now at first, I want to say that the whole software is hardware agnostic. So you can choose by yourself what camera you want to use, which PC you want to use. There's only like a few specifications that you have to take care of. It must be GigE Vision, and it should be an NVIDIA graphics card. It doesn't have to be any AI accelerator. It can be the standard graphic card you use for gaming. And then you're ready to go. So you're firstly collecting a few pictures. And next step, and by the way, most of the time I just click the next button, which is the most easy one, and you have already your good result. You're taking all of the pictures and feed it into the AI training model. We only show a few pictures to the AI model, and a few we never show them, because we have to cross-check how good it is at the end. And after a few minutes, the AI model is already created, and we can see in the confusion metrics, okay, we detected the good, the bad, the false detections, and the false positives. And based on that, it's always a good discussion with the customer to see, does it already fit your expectations? And if yes, perfect. We can already deploy it with a low code, basically drag and drop how we want to react when there's a good product, when there's a bad product. Or if the AI model is not sufficient enough, okay, we just go to the settings. We also have an auto AI modeling, which improves all the detailed and advanced parameters to then have the perfect AI model for you.
Okay, but in that case, you need couple of actions and then only couple of pictures. So what about accuracy of this approach? I mean, how accurate this kind of step-by-step created model can be?
Yes. So normally we are aiming for 95, 96%, for example, but it can also go easily to the 100% detection accuracy. which I saw already many times. I would say it all depends a little bit on the product and picture quality that you're showing. And by the way, we can also do it for you. So we can always do the offline analysis. So you're just sending us the pictures. We analyze it, discuss it with you. So you already see in advance what are the effects for your production line. So you can already decide, okay, if the accuracy is already like 96, 97%, it's very easy to then calculate ROI for you as well. And I think this is the nice thing about the AI visual inspection, that it's very visible how the outcome for your production line will be. So you can easily see how much you can improve your productivity.
So let's say that we have this process completed, that the accuracy is, the level of accuracy is accepted. We can start the process. But obviously with the quality inspection, what matters very much is also how good you can report on that, right? And
Yes.
The transparency of the production process then translates into ability to report the quality of your production. So how do you approach, let's say, this kind of documentation and reporting type of activity that pretty much every factory has to do?
Exactly. Like, very good point. And of course, we thought about it. So everything is inside the browser environment. So you can create the reports that you require, for example, for some period of time. And then you have the detailed explanation. That was the good product. It was good because of. That was the bad product. It was bad because of. And then you see the detailed heat map and all the all the process parameters, let's say, so that you can be sure that also after, let's say, 1 week or after some defect occurred, you can then go back and see exactly why it was then sorted the way it was. And I think now it's time to also show you how to create step by step the AI model. So I will show you in the browser environment how to do everything. And I pre-recorded the video, so let's have a look.
What you can see here is a screen of MELSOFT VIXIO. What I did before was downloading the trial version with the picture set. As you can see here, it's roughly 5 GB. So I just uploaded in advance to save us some time here. So this is everything I did, and let's create the AI right now. So it's a very simple step. I click on New and make my AI 1.0. All right. So the very first thing is I have to select which picture set I'm using. And since I just uploaded one, I click on Next. We have some pre-processing that has, for example, alignment, like with edge detection, trimming or masking, depending on how your picture looks like, if there's some area that you don't need or where you don't want the AI to judge this area. For this example, I will skip this process and go directly to the next step. We have two functions, anomaly detection and defective point detection. Anomaly detection, we use the good pictures for learning, and for defective point detection, we use defective point bad products for learning. This example here, we will use the anomaly detection. So I will click on the good pictures that I want to select, as well as the bad pictures. In this case, we have 3 defective picture sets, and use them as well. Over here we see the green area. This is used for learning or teaching the AI, and over here this is some data set that we don't show the AI in advance. So after creation we show all of these pictures to the AI and see how it reacts. Of course, there's many advanced settings as well, for example, as an AI optimization mode, which goes through all the settings available in MELSOFT VIXIO and selects the perfect setting and tries them out so that the result of the AI will be best for you. I think this process over here, as you can imagine, on my slow laptop, I would say, can be accelerated by a magnitude if you would just use some basic gaming IPC, I would say, with a graphics card and a decent CPU. But nevertheless, This process over here is a very short process. I also will leave it up in real time, so no cutting here. And I would say I'm hoping that it will only take the amount of time to get the fresh coffee. Let's say fresh coffee from a nice coffee machine. And yeah, let's see how it goes. There's also, as I skipped maybe already some parts over here in this very short video, all these advanced settings, for example, they allow you, of course, to add some rotation, to add some brightness deviation as well, and creating artificially new pictures so that you have a bigger picture set to learn from, and the AI automatically will get better results here. I find it highly interesting that since our last update with the MELSOFT VIXIO 1.0c, we got this new AI functionality that the AI will run exactly the same process that you see at the moment, but multiple times. So since one process doesn't take that long, doesn't matter if you can run it multiple times, but it will then use the outcome and compare it versus other settings. So you have to do nothing but just click start, and the AI does everything for you, changing all the detailed settings like variation in brightness, rotation, and so on and so forth to get the best outcome possible. But as you can also see, we just approaching the, let's say, 1.5 minutes mark. I would say prediction is quite right with getting a coffee and going back to your desk. So we are having over here this result. So we are having this diagonal page. The AI predicts it's a good product. It's actually, the AI predicts it's a good product. It's actually a good product. This is perfect. Defective product. Okay, the AI predicts it's a defective product, and it's really a bad quality, for example. It's also perfect. The over detection over here, or let's say this diagonal point, this here is, let's say, worst case. If it's a bad product, but the AI says it's good, it would slip through the inspection and goes to the customer. So I would say this is worst case. Luckily, everything was detected. Over here, we have a slightly high over detection rate. So I would then recommend going through all of these pictures and see if we can increase, or let's say improve this amount or the outcome by, for example, masking. As you can see here, it detects also some outside area. So I would just use, for example, some masking and so on. Then the next part over here I would like to show you is going to the task list. I cannot show you right now how it looks like in the live system. I'm just connected to my laptop. But we have several templates where you say, I want the trigger from my PLC with the connected camera. I want the trigger just by the MELSOFT VIXIO here, or I want to use just pictures from my folder. I will select this template, and this is all low code, so everything is easy to configure, like which PLC you want to connect to IP address and so on, which data you want to map, where to connect the camera, which AI model you want to use, and what should happen in a good and bad case. And with that said, that's all about my very short introduction of MELSOFT VIXIO, the software. So I'm hoping you could already get a brief overview of what we can do in 5 minutes.
So yeah, I think you didn't lie about the speed of deployment. So if the video is only 5 minutes, then clearly you didn't speed it up, right?
No speeding up. So, I think you can see it and hear it on the voice as well.
So the 5 minutes to set everything up, it seems very interesting, I'd say. So this accuracy level, right? So the setup time versus the accuracy level, for me, it's quite amazing. So, okay, I think that this is another use case that shows, in my opinion, how manufacturing can be transformed by AI. However, the AI that is close to the production, right? So you want to allow your AI models, whatever they are, to really understand the context of the production site. And I think that this is another example that exemplifies how important the edge level of AI is. Very good. So maybe as a kind of like a finishing touch, maybe you could tell our audience what should they remember from our discussion.
Yes.
Some key points that should stay with them.
Of course, obviously, when thinking about the production line, OEE is one of the key factors that everybody has a look at. And with the visual inspection system, you can increase the OEE by a lot. Just by, for example, having the high accuracy level, you have the constant quality inspection, so there's no variation, and also you are much faster in that regard as well. Also, I would say you can think about it of reducing also waste or also other material. And what do I mean by that? So if you install the inspection system before some process that is utilizing, let's say, a lot of material or something like this, if it's a bad product, there's no need to process it any further. You can discard it right away. So you're saving money here as well. And of course, also the flexibility that we talked many times about it today, that the creation of AI models is so fast that you don't have to care about having a new variant. You can create your AI model in like a short time and you're ready to go. So overall, I think these are like great advantages that we are creating now with the AI inspection model.
Right. And I think that this, let's say, transformation, you could call it a transformation of the process, can be done relatively quickly. So maybe, let's say, the next action to be taken. How would you suggest that those companies who are looking at those kind of challenges in their factories, how can they try the approach that you're explaining?
Yes. So for sure, we are having like a free trial version. So you can try it out for 30 days. You can contact us, of course. We can discuss like what kind of approach we can take together or with our system integrators. And we also have a very nice video. It's just 15 minutes of your time that you can look at, where we a little bit go deeper into the process of creating the AI model. So if that 5-minute demonstration today was too fast and maybe my explanation was not enough for you, there's another nice video that you can have a look at, and just follow the links. And yes, happy to see you then next time.
Yeah, so we will put all the relevant links into the conversation somewhere. And yes, the trial version is available for everyone. The website provides some additional information, like, how to set up the whole system. So it should be relatively easy. And I think always you are able to have some personal consultation with someone who wants to get more information, right? Of course, yes. So our experts are always waiting for your requests. Very good. So Daniel, thank you very much for this extremely interesting case, and hopefully see you soon. Great. Thank you very much, and see you soon.